I have another question. It's along these lines.
Okay.
So, in lab yesterday, they were explaining when the ventricle repolarizes, that's when it's like squishing all the blood up. That's what was explained to me. Mm-hmm. And I am super confused as to why the repolarization would squish it up. Like, I'm confused as to what is happening during the depolarization of everything. Like
so it should be here, let me.
I don't think it's blood, is it? It's the electrical.
Well, the electrical impulses are the ones that cause the contraction of everything. But I am still unsure of where everything is. Like, what is happening at the P, what is happening at the Q.
Oh, yeah.
Okay, so it might be switched around. I don't know if who or whatever, but the QRS complex, which is ventricular, signals the onset of ventricular contraction. That's depolarization. So we've got this wave, right? So we've got this, and then we've got one of these numbers.
Yeah.
And like that, right? So we're talking about right here, the QRS complex. This is ventricular depolarization, okay? And this is ventricular contraction. Because this is ventricular repolarization.
Right.
And that's when it leads to ventricular relaxation. So I'm not sure, because you said that they said that this was repolarization and that's contraction.
Right, because it depolarizes, and then as it's repolarizing, it's like squishing it up. Because you have to start from the bottom and squish it up because it has to go through the aorta. It has to get out there. You can't just like squish it at the same time. Otherwise, it's going to bulge somewhere.
Oh. Yeah, so... So yeah, when the heart contracts, so let's see if I can draw a heart actually. So we've got kind of like the atria, right? And then there's this thick center part, right? And then it comes back up like this. But it goes to a point. So anyways, so all right, and these are kind of separate. Okay, so let's follow this, right? So from right here to right here, this depolarization is this part right here, okay? P wave, right? This is the P wave, okay?
So the P wave is also atrial
depolarization, atrial contraction.
Atrial contraction.
Yeah.
Okay.
And it's like before it contracts though, the electrical signals are going to cross, right? So it's not like it's contracting. It's like it's depolarizing, and that follow that is contraction, right? Because it's not like at the same time, but it pretty much is.
It's like a tag team.
Yeah. Okay, and then we have this signal down the center, right?
Okay.
And this is this part of the wave, okay? All right, and then we've got up the Purkinje fibers up the sides, and that represents this wave going like that, okay? And then after the contraction has occurred right here, we have repolarization of the ventricles. Because after a cell contracts, then it's going to keep contracting until it repolarizes so it can relax, right? And so this is after this happens. So, but what about the atria? Because it depolarized, so when does it repolarize?
It doesn't show on the chart.
Right. Yeah, because it occurs right here.
Oh, okay.
And it's kind of masked by the QRS complex because it's a lot bigger, okay? And so right here is where you're going to have atrial repolarization, right? And that's why this wave, this looks like this. It's talking about the direction and magnitude of the electrical signal in the heart. And that's why you have to set up the the leads in specific spots. Because I think he talked about how, like, depending on, like, where you put a lead, right, determines what the wave kind of looks like. Yeah. Like if it's offset and not straight across like this would be more like you'd get a stronger peak, right? And so they place the leads in specific areas so they can specify kind of and get correct kind of magnitudes. Like if you were to switch the leads like this, then all these would be a lot more shallow and might even look completely different. So, but this is kind of confusing because it looks a lot like what? An action potential, right? But that's not necessarily what's happening, because in an action potential, you have depolarization, repolarization.
Aren't these just like a bunch of action potentials?
Yeah.
Right, it's not just one.
Yeah, and this is like you're following the action potential, right? And what's going on, not necessarily like the cell is depolarizing, that now the cell is repolarizing. You know, it's more talking about direction. And that's actually what I explained wrong on camera last time, because I was like, yeah, it's the ventricles are depolarizing and now they're repolarizing, but that's not true. So anyway, so this is P, Q, R, S, T. And they usually group these together because they all represent ventricular depolarization. It's just that because it goes down and back up, they change direction. Does that kind of make sense?
So when it's going down the middle, it's going from Q to R.
Yeah, it's kind of opposite.
Yeah.
Because we've got right here, we've got, I think it's positive and negative. And so when you depolarize, you're getting more positive. But this kind of is determined by where they put those leads in the heart. So they have, like, I think it's positive and negative, right? And so it's, or maybe it's opposite. I'm not sure how to set up leads, actually.
It's negative to positive.
Negative to positive. Yeah. Okay, so if we're going negative to positive, it makes sense that it's going up, right? Because it's going this way. But then it goes positive to negative because it's going this direction, so that's why it's going that way. That kind of makes sense? Mm-hmm. Cool.
So for the ST segment, is that ventricular repolarization?
It's just this T wave.
Oh.
That's ventricular repolarization.
Oh, okay.
And I mean, I didn't space these really correctly because technically, yeah, you're right. It's kind of like this, right? Okay. It's kind of like, well, it's actually.
So is that?
It's actually like kind of like this, right? Uh-huh. So I just kind of space it out because I don't know how to draw it very well. But.
So where in that graph is the blood going through the semilunar valves?
Through the semilunar valves, somewhere in this QRS complex. Okay, because this signals like ventricular contraction, right? And so during ventricular contraction, period of ejection, like that's what's going to happen. But like I said, it's not like it's a little bit delayed behind this electrical signal, right? So it might be like if you label this as time, it might be like all of this. If it was like this represented contraction, it would be like delayed a little bit. You know what I mean? Or yeah, delayed. So the electrical signal would happen and then the contraction would happen, but it's like right after each other, right? So this is hard. Okay, so this is hard stuff. Honestly, I don't even know if I really understood this when I took the class. So
is the T really that, I guess, important?
Is the T wave?
I guess it's all important, but like the T wave is.
So the T wave is important because it relaxes the heart muscle. So if there's no T wave, the ventricles would never relax. So it'd be like boom, and it'd be like.
So T wave is the relaxing of muscle?
Yeah. Yeah. So it repolarizes, so it makes it so it goes back to relaxation phase.